Hi everyone. Recently spent some time in the city of Freiburg, a charming place in southwest Germany in the Black Forest. Now, this area of Switzerland, southern Germany, has historically had great thinkers and great professors and highly acclaimed universities. And I found out one of the world's top astrophysicists, Dr. Bergigina, was here. She is looked at as a world expert in how the universe works and in exoplanets. She does TED Talks and is well known in astrophysics circles.
Out there in the universe. And the Earth is just one of them. In this universe, we are really tiny. We put Earth in the center of the universe. Then we realized something wrong with it, so we put the Sun in the center of the universe. Again, it was a little mixed. We put Milky Way in the center of the universe. Not so bad. And we found out in the end that there is no center of the universe. Our planet is just a single blue dot among billions of other stars and billions of other planets. We use these plants as prototypes of photosynthetic organisms in the universe. And then we build models for alien lives, how they could look. And when we puzzled with this question, how aliens can look like, we actually find answers in the backyard. When we detect life on other planets, we will understand and learn that we are not alone and we are not special.
I wanted to interview her, but how? I thought about it and I created an alias, David Howard from Oxford University Media Society, and created some online material supporting this front. After some well thought out, tricky and delicate emails, I got the appointment, and with the backstory that I was collecting information for young students at Oxford. As I waited in the lobby of this advanced university astrophysics centre, I could see that this was a business, with funding, hierarchy, secretaries, etc. Now, before we get into the interview, for those new to the channel, know that gravity is just a theory, and my blog in 2015 explained the errors with gravity, and that it can be explained away by density and buoyancy. This blog had over 50,000 views, with not one person debunking it. Also worth knowing is that in 1931, a book called 100 Authors Against Einstein was published in German, and is in the description. This shows 100 scientists stating Einstein was leading science into pseudo-mysticism, abstraction, and speculation. It was crushed by mainstream science. Also know of the Dunning-Kruger effect, a cognitive bias in which experts mistakenly assess their cognitive ability as greater than it is. It's related to the cognitive bias of illusory superiority, and also comes from the inability of people to recognize these experts' lack of ability. Obviously, in this interview I couldn't say what I really wanted to early on, as I didn't want her to walk out. I wanted her to cover more subjects and get more answers. So take a seat and buckle up, and this gets more interesting as it continues, and presents a big key, one the truth community has needed for a while. Okay, let's play. Yeah.
Okay. And this doesn't go to unedited somewhere. You will edit this?
Yeah,
somehow?
sure. You can swear or go to the toilet or whatever, it's fine.
Okay.
Sure. Hello, Dr. Bergigina.
Hello.
If you could just spend 1 minute or 30 seconds explaining who you are and what you've done.
Oh, yeah. So I grown up in Russia. I fell in love with astronomy, first with physics and then with astronomy. And I realized that I want to understand the universe. I cannot live on Earth without knowing what's above my head. I just felt like I need to know. I went to the university, studied astrophysics and mathematics, lots of programming, because when we were studying astronomy, we were told that astronomy is not just science by itself, it's very interdisciplinary. So to be an astronomer or astrophysicist, you need to know physics, mathematics, programming, and I must tell right now, lots of social skills.
Yeah, sure. Great. I've got a few questions for you, mainly going to go to teenagers. They're probably questions you don't hear often, or you probably heard when you were a lot younger. The first one I'm going to ask is, it is said that a spinning atmosphere has no border, there's no physical border between spinning atmosphere and the vacuum, and the atmosphere gets less pressured and becomes the vacuum of space. At what altitude would you say that the atmosphere stops spinning? So gravity, they say, pulls the air molecules to the Earth, but there's still some atmosphere molecules higher up.
Yes.
At what altitude would you say these atmospheric molecules stop spinning?
Well, this is, I would formulate this question that, yes, okay. So the atmosphere spinning and gravitation forces for molecules, these are two kind of different, let's say, forces, yeah? So the spinning allows molecules to escape, actually, at certain heights, yeah?
Okay.
So they can spin and escape at some point. They escape through collisions also. There's the additional forces, they collide. So
they collide with each other, or with parts
other.
of the vacuum?
With each other.
Okay.
So in order to understand when the atmosphere ends, kind of, yeah, not like having a sharp border, but what we call atmosphere below and no atmosphere above.
Yeah.
Actually, there's another term called exosphere.
Okay.
It's nothing to do with exoplanets.
Yeah.
It was terminology before exoplanets were discovered. It's called exosphere. So that part of the atmosphere which escapes. So below that part, the atmosphere, if it exists, it's called atmosphere.
And it's spinning.
And it's spinning and colliding, molecules colliding. But above, the density is so low that they can escape because they cannot collide. They don't collide anymore.
And what happens to those molecules of atmosphere that escape into the vacuum of outer space?
Oh, they go on a cosmic journey.
Okay, and they stop spinning with the Earth.
Yes, they don't belong to the Earth anymore.
Okay.
Yes.
Is there a set altitude, distance, where that happens?
Yes, of course. It is defined by density of the atmosphere, the gravity of the planet. But for the Earth, I have to look up. If you want me to look up, I look up.
No, that's fine.
I don't know that number. I know that the density falls off exponentially.
Yeah.
So I actually cannot say. I mean, we tell that the space starts approximately, let's say, at 100 kilometers, above 130 kilometers, something like this, that you can go on an orbit. I mean, this spinning means like the body spinning around the Earth means that it's orbiting Earth, yeah?
Okay.
So even if we put a satellite at 200 kilometers, it's still orbiting the Earth, even though it is not in the atmosphere. So we put satellites at thousands of kilometers above, and they're still spinning around the Earth.
They're still in low Earth orbit in this model.
They're still on the orbit. They're still spinning around.
Would they still be colliding with molecules of the atmosphere?
Yes, they will. If there are,
okay.
At that height, yes.
Okay, great.
So everything is spinning around. All the also space junk, what we call, all this.
I've got a question on that later.
Okay, good.
Okay.
So everything is spinning. In my terminology, it's orbiting. Astronomy terminology, it's really orbiting the Earth at very large distances. Moon, 400,000 kilometers, is still orbiting the Earth.
And this would also collide with escaped atmospheric molecules from the Earth?
Yes, and it also collides with the escaped molecules, and not molecules in this case, but more like particles and atoms from the sun.
Okay.
Which is called solar wind.
Okay.
Yeah.
Okay.
It's like hard to, I mean, the atmosphere definition is that, okay, when the molecules can escape, the atmosphere ends. You have to look up this number, for the Earth, I don't know.
But it's kind of arbitrary and it's kind of hazy.
Yeah, exactly, it's just escaping. But this escape, it's still, they can go on an orbit.
Yeah.
It doesn't mean that escape means that they cannot fall on Earth anymore, because the molecules go like this. Like they collide and they go up and down all the time, So it's like turbulence, what we call.
And the reason in mainstream astrophysics that the vacuum doesn't suck out the gas is because the gravity is holding the gas to the Earth.
Yeah, exactly.
Because everywhere else in science, when there's a vacuum and gas, it equilibrates.
Yes. If you just take without gravity, yes, then they start to mix. Yes.
Okay.
Our survey said.
On to the next question. It is written in astrophysics that the rotation of the Earth is due to, we can't feel it because of constant velocity. Now, one astrophysics guy I met, he said there are two constant speeds. Let me show you this.
Yes.
A bit like this fairground ride.
Yes.
And some people I know looked at some rotation physics, and they said if you're on the edge of this, you would be experiencing acceleration and deceleration. It's only the middle point that would experience, like the wizard in the middle. The wizard would be constant velocity, but if you're on the edge, you get acceleration and deceleration because of the two constant speeds. How would you answer that?
You mean why this happens, or?
Well, surely with the rotation of the Earth,
Yeah.
and because it's going around the sun at 66,000 miles an hour,
Yeah.
we'd be experiencing deceleration and acceleration. So think of this fairground ride. Pick one human being. So pretend that's the Earth.
So you want to include all the velocities involved, also Earth
Just two.
rotation.
The Earth rotation on its axis, 1,000 miles an hour, and 66,000 miles an hour around the sun. If you're on the edge of this sphere, like a human being, you would surely be experiencing deceleration and acceleration.
Exactly.
How does astrophysics at your level explain that?
Well, it's gravitational forces. So one gravitational force you have towards the Earth center. So this is gravity of Earth, and that what holds Earth together. And when it rotates, you experience this acceleration on the edge of the Earth and the gravity towards the Earth. But when the Earth goes around the Sun, there is gravitational force towards the center of the Sun. So two gravitational forces produce this effect of acceleration and deceleration combination.
Bingo! Yahtzee! Is that your final answer? Our survey says.
But wouldn't that mean we're not at a constant velocity, so humans should feel the rotation of the Earth?
That is interesting.
It's an interesting one.
Yes.
The astrophysicist I met, he did a model showing that it should show acceleration and deceleration. So I could actually show you a video where this goes around the sun, and it shows, and even you can go onto the International Space Station, which is orbiting the Earth, and this also should be showing acceleration and deceleration due to the two constant motions, just like the fairground ride.
Right. Well,
probably need some homework.
Yeah, I need some thinking.
But it's an interesting one, yeah?
It is an interesting question, yes. We usually think, that the pull, we have to compare this acceleration to the gravitational pull.
Okay.
That I would start with, because velocity is one thing, but acceleration is the other thing. So we have to compare acceleration due to rotation to the acceleration due to gravity.
Yeah.
And it's very possible that gravitational acceleration is larger. That's why we just don't feel this side.
I think we would need three different answers. One for the Earth, one for the International Space Station, and then one, imagine an astronaut outside the International Space Station.
Yes.
How would he be staying with the space station? Because they're all doing this they're all acting under these two constant forces, two constant motions.
Exactly, yeah.
So this is a question I can't get answered. It's a very interesting one.
Yeah, but in this case, space station and the astronaut in space, they are like we call it probe particles, free particles to probe the gravitational field. Yeah. So they will orbit the Earth because of the gravitational pull of Earth, but together with Earth, they will move around the Sun. So, and that is because the gravitational acceleration of the Earth to the Sun is much larger than gravitational acceleration of any of us to the Earth.
So they just don't notice it?
Yeah, they don't notice this.
Okay.
So that is, I think this, of course, the rotation around the Sun, orbiting around the Sun, it's a huge velocity. But we're so pulled to the Earth that this Earth to the Sun is somewhere.
Our survey said.
This is a quick question a friend wanted me to put in. He said, with the lunar lander, there's one rocket. How would that land with one rocket when the spacecraft is asymmetric? Like, we haven't seen on Earth a craft landing. I mean, the SpaceX one, they say lands, but that's very symmetrical. So it's a very asymmetric lunar lander.
Yes.
Surely we'd have seen that being tested on Earth, or we'd see things now.
It's jumping, yes. Did you see the movie of First Man, it's called? How he practiced, I mean, in the movie, he practiced landing on this. Okay. And it was jumping like hell, like this. And he said, I will practice until I make it, you know? So it's probably some also human skill involved in there.
Maybe a bit like when they did a manual docking with the ISS.
Yeah, it's all, I mean, this Apollo 11, it's all manual. If you go to Smithsonian, it's shocking. They use the calculator smaller than we use in our...
4 kilobytes memory.
Smaller than we have in our telephones right now. It's all manual.
Yeah, and they had when the lunar lander took off, they filmed it. You know that piece of footage? The lunar lander takes off from the moon and they created a film. It was like a 10-second film of it taking off. And my friend asks, who filmed it and who... How did that?
They left probably cameras there. That's fine.
And then went back to get them.
No, they get through radio, pictures through radio. You get.
So in the 1960s, they sent videos, digital videos, back across space.
Well, it's radio. So let's say they can take pictures.
But they only had a 4K memory lunar lander, and now you're saying they had like a 20 megabyte ability to capture video. This is a strange one.
Come on, we have pictures from the missions.
But as scientists, we can't take pictures as proof, can we?
I don't know what was the technology, but in 1960s, this is 69, okay? So there were already missions to Venus, Mars, also lunar orbiters existed. They all sent pictures. Pictures from the back of the side of the moon were sent before.
I, as an independent journalist, I can't use pictures as evidence, because we can watch a film, a science fiction film, and they've got great pictures of space.
No,
you know?
no, come on. Pictures is data. Pictures is data. So, of course, you can fake pictures. In our time, 21st century is unique. We fake everything. So, I don't think in 20th... Well, of course, you can fake also all the times, or in 15th centuries as well. But if somebody... I mean, this is unethical, again, yeah? So... I mean, first approach should be like, okay, you have picture, this is data. I look at it.
Yeah.
And if I have questions, I will ask, how did you get this data? Yeah. And the person who claims that this is a data, he has to provide all the materials.
That's true.
Prove that this is real data.
That's true. And with the moon mission, they said 2 years ago they've lost all the data. You remember that? They said they've lost all the data. Because some people went to say, oh, can we study the data? Because they had some questions, like I have. And they said, oh, we've lost it all. Can't find it.
This is also, this is another force called government, okay?
Things get a little shady sometimes.
Yes. Sometimes governments want to hide things, we know this. And they can say we lost it instead of sharing them, for instance. I don't know. I looked at pictures of the lunar orbiter, for instance, of the surface of the moon, and there is clearly landing sites there. You can tell me that, oh, that picture was faked, and that's why when you look at the data, the landing site is there. You can tell it's possible, yeah, that somebody faked that. But it's also, then, of course, in this case, I can say, all right, some data faked, what can we trust here in this universe?
You would say it's healthy to trust photos and images from bodies like NASA?
Well, I mean, what can we trust then? I don't know. I mean, if we question everything,
then we end up crazy, maybe. Yeah,
we should hold on something,
Yeah.
And NASA, I think, safeguard its reputation. I would say, trying very hard. all of us, all scientists do that. But when the government is involved, I don't know what happens. So that I can imagine that there are forces saying like, we don't want you to share this data,
Sure.
and then the scientists are constrained, and then you can call it unethical from our outsider point of view. But for those people who work there, this is maybe a threat of life, you know.
Sure,
And so it's a controversial thing.
Yeah, because NASA is a government agency.
Yes, exactly. So
yeah.
I don't know what they hide. I cannot prove or disprove because I'm an outsider.
Sure. Two questions about the space station. I think a year ago they had some cracked glass on the space station due to space debris. This was put all over the internet and mainstream media, but yet they still did spacewalks a week later. Would you think that's a bit dangerous to do if you're getting the screen cracked by space debris? Surely if you're an astronaut, you'd be like, hey, I'm not going out there next week because my spacesuit, I'm going to die. There's a good chance of dying.
Well, this space debris is being tracked. Not everything is known, but there are telescopes on the ground which tracking this little specks in the space and calculating their orbits. There are catalogs of this space debris, and they are like not homogeneously distributed all over. There are like packs of them, like in that, remember the movie Gravity again, like they say, oh, it's coming, you know, like this is space debris from particular mission, and it's true that they are distributed unevenly. So there are some dangerous times and there are not so dangerous.
Do you think they're just brave astronauts?
God, it's another force. You have to do things, you know, it's your job. And of course, I'm sure the government takes all possible care that people are not damaged there. But if it's a job, you just do your job. Yeah. You given the order, you do your job. You know, I think this is
military style. Yeah. Going on to something a bit interesting here. This is recognized all around the world as the spherical trigonometry of the curvature of the Earth, So, do you prefer kilometers or miles?
I prefer kilometers.
Okay. So, if we were to look, let's try and make this brighter. If we were to look 50 kilometers, there should be 195 meters below the curvature. It's 195 meters drop. Does that make sense? So if I walked in a straight line 50 kilometers, I would have dropped.
Okay, because of the curvature.
Because of the curvature of the Earth. This is, how much is that? 195 meters.
Okay.
Yeah? So for 20 kilometers, there will be 31 meters drop. This has been verified through universities and astrophysicists. What if I told you I knew some people who, over 4 years, have done about 50 to 100 experiments, and they can see lighthouses and have done laser tests over between 30 and 60 miles. So like a laser hits a mirror across a long lake, like Lake Constance, near Constance, near here, and seeing things like Chicago's skyline from across Lake Michigan from 50 miles away. And they factored in the height of the person and all the maths, and that these people actually cannot find the Earth's curvature. For instance,
I didn't understand what they say.
For instance, I have a video here. I just want to show you some tests. So this guy has done some tests. Where are they going to be further on? And there's many using the P900 camera. Have you heard of this camera? It's 86 times zoom, and it's only come out recently. These people have done tests over 10 kilometers, 20 kilometers, and they can see torches, mirrors, lasers, where they've done the maths and it should be 10 meters below the curve or 20 meters below the curve. And this is getting really strange really quickly. He's saying here, he's done the maths, I verified some of it, so this should be 21 feet below the curvature. This is only over 7.53 miles, so this is 10 kilometers, let's say. He's factored in the camera height, and there are curvature calculation tools, and he's seeing lasers and mirrors. And there are people I know, especially in America, who are doing loads of these tests, and they can't find this curvature. What would you say to these people?
They have to take into account the height at which
They
they
are.
stay.
They are.
And the height of the mirrors.
They are. Even if it's 50 centimeters, they're putting that into their calculations.
How do they measure the height of their own height on the Earth? They have to know it very precisely. If they want to measure 20 feet.
Sure. What they do, they're actually generous. So say they set up a tripod at 1 meter. They actually put into the calculations 2 meters.
No, I mean height, like relative height of you because Earth is not really round. Yeah, it has bumps. That's what I mean. How do you take bumps into account?
There's an oil rig one. This one's quite far. This is like 20 kilometers.
Yeah, you have to take the profile of the Earth.
So you're saying
geography.
Saying they're just finding a. So this is really interesting. This is 3 oil rigs, and the furthest one is 26 miles away. You shouldn't be able to see it. I mean, we can say the Earth is flat in some places and more curved in others, but these guys have done so many tests. This is 26 miles away, and the horizon's behind it. Now, they say in mainstream physics, the horizon's 12 miles away. With this new camera, the P900, they're seeing things 20, 30, 40 miles away. And this is getting pretty crazy.
I don't know. This is, again, like the facts you bring, I don't know what these people are doing, first of all.
They're testing stuff with their eyes because they don't trust the governments, these people.
Oh, Jesus Christ, I don't want even to talk about this, I'm sorry.
Why don't you want to talk about it?
This goes crazy.
But this is science, right? You're a scientist.
No,
you're a scientist.
I don't accept this.
How can you not accept it? It's right in front of you. The oil rig's 21 miles away.
No, I don't. I want to have.
This is a test. It's a scientific test.
Who did this? Can I trust those people who published this picture?
I'm verifying these people. I know these people.
Well, okay, but this doesn't tell me anything.
Okay, how about you and I go to the lake one day and we take a P900 camera and I'll show you something really, really fucking crazy.
Well, again, there are forces in the universe, yeah? So there is atmosphere, you have to take refraction into account, you have to take geographical profile of the surface. It's not that, oh, I take a camera. You know, I have these people visiting me sometimes.
But they're not doing it, but they're doing lasers as well. You know there's lasers that cost $2,000?
I know.
And there are people who've done 25 miles, 30 kilometers tests.
I can see mountains 40 kilometers away.
Yeah, but they're high up.
Why do you claim that this is not high up?
Come on, you're smarter than this. Say you have a lake, 30 miles, water's, yeah? And you have a person here firing a laser, and you have a person here with a mirror. And
why do you claim it's on the same...
there should be curvature. With the official size of the Earth, there should be detectable curvature of about 30 meters in some cases, maybe more. And people can't find it.
There are other things to be counted. Not only just claiming, oh, there's no curvature. You have to count shape of this thing where the water is, how it feels, what's the gravity there. What is the
gravity there will be the same as the gravity everywhere.
Refraction of the atmosphere.
But okay, there's a test where a guy went back every day and did the same test because of different atmosphere, different atmospheric haze.
This refraction is on average always the same.
But refraction can't make a human being jump up 30 meters.
You can see light of the sun from below of horizon.
Sure. This is like refraction, I understand this,
yes.
But what they did in one test, he proved that it's not refraction because there was a tree above the person here, and you could see the tree and everything. He said, well, where does the refraction start and stop? You know, like a mirage.
Okay, so for me, it's not science if somebody says it.
But there's tests.
We have, in science, we have a system. We don't believe everything what people say or what they measure. They are publishing results in scientific papers. There is always peer review to that. Sure. And if there are questions to the results, they have to provide all the data, all the measurements. And even if it's published, It's not if it's just somebody published this
Yeah.
and somebody repeats it and cannot reproduce it.
This has been repeated. I could show you 50
Is it published?
different people.
In which journal is published?
I could tell you for a fact that mainstream science is really not happy with these people and is shutting them down. And I could tell you another thing for a fact, that governments and government websites
So what
are
are
also not happy.
what are you claiming?
I'm just not claiming anything. I'm here to ask questions.
No,
I don't have
what
any
are you
conclusions.
claiming? That these results prove that Earth is not curved.
I'm not saying that. I'm not making any claims and I don't have any labels. What I'm saying to you is, this is strange. What do you think?
I think these measurements have to be verified by scientists. It's like claiming
But everyone's a scientist.
UFO. No, not
I disagree.
everyone. We are trained. We are trained as scientists. We are trained with the analytical skills and scientific judgment. Even if we don't know something for sure, we can judge based on the other lots of knowledge of scientific facts.
Okay.
And not everyone can do measurement and say, look, I measured this. How do you prove it? I had one crazy person visiting me, taking pictures of dark places with the flash. And she was claiming there are these little dust particles which she sees on the flash picture. These are UFOs.
Yeah, that's crazy.
Yeah, that's crazy.
Okay,
but this is the fact.
Sure.
She took a picture of the dust particles, scattered light.
Sure.
But her interpretation was, these are UFOs.
But if 100 different people have done this test with this new camera, 86 times zoom, at lakes, all around the world, peer-to-peer, there's a place peer-to-peer in England, and they're getting the same results of missing curvature, that's scientific method, observable, repeatable, measurable. That's the scientific method. And you replying the word refraction isn't the scientific method.
It is? Refraction?
Well, where's your results that show refraction explains these tests away?
I can see sunlight from the behind of the horizon when the sun is down.
That doesn't mean that humans can jump up 30 meters.
What do you mean jump?
Okay, so say this human and this tree should be 30 meters below the curvature. You can't use the word refraction for them jumping up 30 meters, the tree and the person.
Why do you claim that your calculations are right? I'm not verifying right now.
I'm pretty
anything.
smart. I'm pretty smart. And
Okay,
I verified.
fine. I have to
these
trust you. I see you first
but
time.
But that's what I say to you. I could send you some data for you
I don't
to
want
do
it.
some.
Thank you.
But that doesn't make you a scientist.
No. It means that I don't want to do this particular project because I'm interested in many other projects.
But you're coming to conclusions without doing tests. That's not very scientific.
I'm not making a conclusion. Any.
But as an astrophysicist, surely you'd want to look
No.
at something like that.
No.
Why not?
I'm not interested.
Why would that be?
Because I'm busy with many, much bigger questions than that.
And you think this is nonsense?
I think it's nonsense.
The detectable curvature.
Yes.
Our survey said.
What would be your first reason for this being nonsense?
Because it's proven curve is round.
Could you show me the scientific methods experiment that did that?
Oh yes, it's done in 2,000 years ago.
Which test was this? Is this the sticks in the ground one?
Sticks in ground. Ships on the horizon.
I could show you with this camera ships, they go over the curvature. I could show you them coming back,
Okay.
reappearing.
So it works?
Huh?
So it works in your case?
What I'm saying is the human eye has a vanishing point in these tests. I'm not making any claims. I'm just trying to find things out. The human eye has a vanishing point. That's not curvature, it's the human eye's vanishing point. Ships go beyond the vanishing point and people say it's the curvature. I can prove to you today if you want, with this P900 camera, the ship comes back.
I didn't understand that.
Okay.
It's okay, fine. I'm not going to talk to people who claim that Earth is flat.
I'm trying to find answers to some very interesting
it's
things.
It's enough for me. It's enough of nonsense. That woman was coming to me 3 times and always.
But you can't project her onto me. I'm a completely different person.
I am sorry. Do you say this picture is the data? She claimed exactly the same.
No, but this isn't picture. This is video. This is video.
It doesn't matter. It doesn't matter.
So if I showed you 1,000 videos...
It's interpretation.
Okay, if I showed you 1,000 videos of PhD scientists doing this, these aren't a bunch of idiots, these are scientists, a lot of them are PhD scientists. If I sent you 1,000 videos from PhD scientists doing curvature tests, you would still say it's nonsense.
PhD science in what?
Many different, I mean, some are civil engineers, some are all sorts of different things. Some are astronomers.
Well, let them publish this. I want to read that paper.
But when they publish it, do you know what happens? It gets shut down.
Yeah, I want to read that paper.
No, the paper's not allowed to get out there. You even put a video on YouTube, they turn it off.
I'm not talking about this. This goes into a direction I don't want to talk about.
But this is science.
No.
Because it's measurable, repeatable, observable.
It's not science.
Why would you say that? Why would you say this isn't science when people are doing tests and capturing data?
Because of that woman I told you. There are pictures, these are data.
But as a scientist, you should say that was her and this is something different.
No.
You can't project an old issue onto a new issue.
No, I give you example. By exclusion. Try exclude that picture was, you claim that every picture is a science. It's data, I agree. This is data, somebody recorded it.
Yeah.
What comes after data is the analysis of the data.
And that's what's happening in these videos.
How the analysis is done, and after the analysis there is interpretation of that analysis.
I can show you hours of this.
And
This is the data, the curvature model that every university in the world goes with.
Fine.
And this has big problems.
Make these measurements on the moon. Make these measurements on the moon. Make these measurements on the moon.
How would we get to the moon? They said they lost the data recently.
And you will, go to the moon yourself. Go to the moon yourself.
But we can't go to the moon.
Yeah, so what can I do?
But NASA said that last year they can't go to the moon because they lost all the data.
Well, sorry. We live on the planet with the water and the atmosphere and gravity and uneven shape. And if somebody measures something which doesn't fit exactly circle of the Earth, I'm sorry for this person, because this is idealistic model.
You think they just got lucky and found a flat area?
I don't know what, it's probably just whatever. It's randomness. They have to make, in order to prove that Earth is flat, they have to take million measurements at million places.
I would say there's about 500 measurements of lack of curvature that are very well done with calculations.
It's your judgment.
No, it's not my judgment. These are not my judgment. They exist. These tests exist.
They are claims.
No, they're tests.
Claims.
They're actually tests.
These are claims. If they are not verified, these are just claims.
But you're saying they have to be verified by the scientific community?
Yes.
What if the scientific community at a high level is just shutting this information down?
Well, I can tell you. You can go and collect leaves, for instance, yeah, because it's interesting. It's biology. Yeah? You collect leaves, it's biology. You come to the biologist and you say, look, this leaf is a little different than this one. How would you explain this? And he says, well, it's just natural variations. I'm not interested in this. And you say, oh, you are a biologist and you're not interested in this interesting thing. Why this leaf is different from that? It's biology, it's science, and you're not interested.
These aren't like different leaves. These are the same, different tests of the same thing coming with the same results. That's highly scientific.
I should have asked your credentials before I talked to you. I'm sorry.
Here she demanded that I stop the recording, as she was super flustered and angry. Now, before I tell you what happened, just remember what she said earlier in the interview.
This is, for me, as a scientist, we're always like, okay, there's a puzzle, there's observation, which is true, data, and there's a model which cannot confirm the data. And I'm sorry, the model is wrong. So
you would say direct experience is the king.
Yes.
So she is a contradictory mess of a scientist. And this person is one of the world's top astrophysicists. It's laughable. And regarding the oil rig, I mean, in the words of Nathan Oakley, if you're a fundamentalist religious zealot, then that's not an oil rig at 26 miles. That would be a slightly looming non-standard refraction high in a holographic projection of an oil rig from behind the reified edge of a sphere based on an R value, turning the oil rig which seems to be there into an oil rig which is not actually there. That's what you have to assert if you are Professor Dr. Bergigina, who is paid well to mind control young humans into thinking the same. So she then demanded that I delete the interview. so I secretly uploaded it to the cloud as I kept her talking and calmed her down. She then told me I would need written permission to publish this anywhere. I'm afraid that's not really wakey-wakey policy, as there's a bigger picture than her theoretical pseudoscience supported on the foundations of fragile egoistic arrogance. I could say to her that anyone mind-controlling mass groups of humans knowingly or unknowingly needs written permission from wakey-wakey, so it works both ways. I also do want to share my credentials. 50 metres swimming. That's it, as I left school at 15 because my soul knew it was all a load of garbage. And in that interview I think I'm the one that stayed rational, and she's the one that got emotional and flustered and defensive. You see, it's all about the elite building and paying for gatekeeper temples, and getting young people to pay to worship at them. It's a clever trick. The questions she couldn't answer are all answered in my Luminaries Mysterium documentary, where just 1 hour after I uploaded it, YouTube really shut me down and hid me from the search algorithms and removed subscribers without them knowing. My plan didn't end here though. I created double-sided flyers that are downloadable in the description, and a linked Instagram account full of memes, and then bombed the city, mainly student cafes. This whole method of undercover interviews and flyers is simple for anyone to copy and paste into other cities. I've shown you how easy it is. I've shown you that the top astrophysicists are frauds. You have the tools, as they simply have no scientific method proofs. It makes it fun. The second undercover interview I did in Freiburg was on a different subject and will be online in a few weeks' time. I also have some new t-shirt designs I'll share in a moment, and as you know, I do professional true cosmology astrology stroke luminology with over 250 happy clients now, and I also give advice regarding the understanding and investment into crypto assets. Oh, and whoever it is who keeps getting the secret police to stop me in different countries and point guns at me for no reason before strangely letting me off, just come and have a chat and a cup of tea, mate. It comes across like you've watched too many 80s B movies and think you're all Miami Vice or something. Just need to grow up.